Assalamualaikum and good morning to our beloved lecturer. Today, we would like to present our project 2 in feasibility design from Group E. In this presentation, we will cover the following section, included introduction, project methodology, data collection, result and analysis, and lastly, conclusion. Next, this is our team member, Loh Chayun, Tan Binji, and me, Nur Hidayah. I will go to the chapter 1, introduction. Problem statements state that ineffective facility layout can lead to several operation inefficiencies, such as a longer production run, increased operational costs, and suboptimal use of space and resource. This problem is particularly pronounced in the furniture manufacturing industry, where the complexity and variety of production process demand effective facility planning. Our project focused on locating and improving factory layout for industry using metal, wood, or both, with the flexibility to include industry dealing with plastic. We aim to combine quantitative and qualitative data. Next, our objective is we want to use different methods to create layout alternative. The second is to evaluate this industrial layout alternative and recommend the best layout along with necessary supportive facilities. And the last objective is to apply different line balancing rule in analyzing the production process. Our scope study divided by two. First one is production focus. Our study focus on planning a facility specifically designed to produce my dream bed, which are 3 bed in one and wooden chair. The second focus is to design our facility layout. We aim to optimize the factory layout to make the special need of producing my dream bed and wooden chair. Assume the availability of necessary resource, including skill, labor, equipment, and material. Next, this is our product, which is the product one is my dream bed. Three function in one product, and the second one is a product 2 is a wooden chair.
Next, I will present about the project methodology. So for the methodology, the information from online source such as manufacturer, website, technical specification, and industry catalogs are used to estimate machine size and workstation space requirements. The bill of materials and product structure will create to list every part and material needed for the manufacturing process. Next, the material flow between the workstation was examined using the Form 2 chart. The relationship chart was utilized to assess how various workstations interact with one another. The largest candidate rules, Kilbridge and Webster method, and rank positioner weight were used to distribute tasks evenly across workstation. So on the right hand side show the process flow chart for this project.
Next, I will go to product structure and data collection. In our data collection, we begin with an in-depth analysis of the product structure for both my dream beds and wooden chair. The product structure serves as a detailed blueprint, breaking down the entire production process into distinct steps from the initial raw material stage to the final finished product. This is the product structure for product 1. For the dream bed, we identify the starting materials such as a various type of wood, metal component, and fabric. The production process involves several critical steps, including cutting the wood to precise the dimension, shaping and assembling the wooden frame, attaching the necessary metal part for functionality, and finally upholstering the bed with the chosen fabric. This is our product structure for product 2, which is start with the three level. With level 1 is a leg assembly, seat and bed assembly, and the second one is the assembly for each of the three in above. Next. Okay, the bill of material is another crucial component of our data collection, providing a comprehensive and detailed list of every material required for the production for both products. The BOM includes a variety of wood types, screw, bolt, hinge, metal materials, and finishing products such as a varnish or pen. Each item in the BOM is specified in detail, including quantity, size, and other relevant specifications, ensuring that we have a clear understanding of all material needed. For the wooden chair, the BOM lists the type of woods, adhesive screw, upholstery material, and finishing product. This through documentation is essential for planning and budgeting, as it gives us a clear and organized overview of all unnecessary materials. Next, this is our process chart for product 1 that we can see that the process for the all process that we have to make in the product 1. Next, and this is our process chart for product 2. And we can see clearly the process from the raw material until the product is completed. Next. Okay, this is the element time for the product, which is we measure the duration of cutting, shaping, assembly, and upholstery. Similarly, and the precedent relationship to define the sequence of tasks by establishing which tasks must be completed before others can begin. Next, I will pass to my team member.
We explain about the formulation of alternative solutions. So for the annual demand for the product, for our first product, my dream bed, with the assumption of annual demand 1,000 units. For the second product, wooden chair, it's also assumed with annual demand of 1,000 units. Since there is assumption of first product and second products, the demands for the sub-products is also assumed with 1,000 units each, which the first until the fifth product is the sub-product for the my dream bed. And the number 6 sub-product is under wooden chair. This is a table of product outline for different products with total demands, which this table clearly shows the product path of the production process to manufacture the products, which for my dream bed is shown in first, second, and third columns. which the production of the second product which wooden chair is shown in the number 4 column. This table shows the front chart for the sub-products, which starting from cutting departments to warehouse departments, which the transportation of the products, transportation of the sub-product between different departments was shown in the tables. This table shows the simplify of the front chart for the sub-product, which the bottom left corner of the triangles was combined with the top right triangle of the front chart to easy the analysis for next step. This is the real charts construct based on the front chart construct previously, which based on the creations, the number of ALU was calculated, which number of A is 2, E is 4, I is 6, O is 8, and U is 16. So by filling the ALU, the real chart was constructed, followed by the activity relationship diagram of the departments, which this diagram shows the closeness between different departments. The highest, the more the number the line between the departments, the requirement to place together between two departments is more highest. This is the result of semantics layout planning, which the table for the size of large machine used is shown in the left-hand side, which the dimension of different machines was shown based on the requirement of the process in previous departments. The size of each department was designed as 7 meter in length and 5 meter in width, which the arrangements were shown in the right-hand side figures. This one is the different iterations for the pairwise exchange methods, which involve the exchange between two departments from the arrangement and size of department in the right-hand side figures. So totally have 36 exchange of departments, which starting from exchange of department A to B, A to B until H and I. So later we discuss about the result in data analysis. This is the result for the systematic layout planning and pairwise. Based on the pairwise exchange methods, the lowest cost for the exchange of department is between department A and C, which the iteration of or arrangements of department is C, D, A, D, E, F, G, H, I, with a lowest transportation of 205,000 meters. So this is the final arrangement of departments based on SLP and pairwise exchange methods. This figure shows the macro view for the production departments, which start from department C, department C, department B, department A, department D, department E, until department I with the dimensions.
So next I will discuss about the line balancing. So from here we can see that the table of activity with time of work element. So the activity is start with cutting, drilling, welding, grading, sandblasting, powder coating, curling, sanding and blowing, apply finishing oil, apply epoxy racing, drying, prime the surface, painting, and also the last process is assembly. So after we have this table, we can construct the precedence diagram for each activity. So from here we can see that which process must occur before the next process carry out. So our assumption for line balancing is 8 hours working days and 10 daily outputs. So the cycle time is 48 minutes per unit. So next. Okay, so the first method that we use for line balancing is largest candidate rule, LCR. So here we need to rearrange the work element from the largest work element time to the lowest work element time. So from here we can construct the table for LCR. So as a result, we can conclude we can simplify all the activity to 4 workstations. So based on this table, we get the line balancing loss is 9.9%, and the line balancing efficiency is 90.10%. So next, this is the precedent diagram of according to the stations. So from here we can see that station 1 including the activity A, B, D, and C. Station 2 include the activity E, H, and I. Station 3 include activity F, J, K, and station 4 include activity G, N, M, and L. So next is Kilbridge and Weston method. So Kilbridge and Weston method will distribute the activity according to the column. So we need to arrange the activity according to the column from the smaller column to the larger column. So next we arrange it, and we need to arrange for each workstation, make sure the total time at the station is not exceed 48 minutes. So from here we can get the result which is 5 working stations. So with the line balancing loss 27.92%, and the line balancing efficiency is 72.08%. So this is the precedent look for the precedent diagram for the Kilbridge and Weston method. So next, for ring positional weight, the it will follow the RPM for each activity from the larger RPM and arrange to the lowest RPM. So after that, it's same with the previous two methods. We need to make sure that every workstation, the total time at each workstation are not exceed 48 minutes. So after that, we get the same result as LCR, which is 4 working station, and the line balancing loss is 9.9%. Line balancing efficiency is 90.1%. So next, this is the precedent diagram for rank positional weight method. Okay, so next I will pass to Hidayah for parking space.
In designing the parking space, we base our layout on several key assumptions. Firstly, we assume that there are 13 workers who each drive a standard car to their facility. This number corresponds to the number of workstations, ensuring that each worker has a designated parking spot. Additionally, the design assumes that the parking space will be utilized during standard working hours, with all employees arriving and departing around the same time. The parking space design follows specific dimension to optimize space utilization while ensuring ease of use and safety. Each parking stall is designed with a width of 8 feet 6 inches, providing sufficient space for standard car. The stall depth is set at 13 feet, accommodating the length of most vehicles comfortably. To maximize the number of parking spots within the available area, we opted for a parking angle of 70 degrees. This angle allows for efficient use of space and facilities, easier parking maneuvers, compared to 90-degree or parallel parking setup. Next. So next, we based on 4.1, we based on the information group to standard car, and on the 70 degree, we get the 57 feet and 10 inch. First, we calculate the parking width using the formula PW equals to SD over sine theta, and we get the meter 2.79 meter, and then by the definition, we calculate the Y, we get the 1.34 meter, and then lastly, we calculate the module depth with the formula Y plus number of stall times PW, and we get the total module depth is a 20.86 meter. Next. Okay, for the layout, the parking lot is designed with a double loaded layout, meaning that parking spots are arranged on both sides of a central site. This configuration enhances space efficiency by allowing more cars to be parked within a given area. The central site is wide enough to allow two-way traffic, ensuring that cars can enter and exit without difficulty. The total number of parking stalls is 7, fitting neatly within the allocated space and meeting the requirement for 13 spots.
I will discuss about the discussion and conclusion. So first for discussion, for the activity relationship chart and systematic layout planning SLP, highest flow intensive of 5,000 units, which department H and department I, department B and department C. So the highest closest relationship are 4 line, which is department B and C, department H and I. Three line closest relationship is department D and E, department F and G. So other relationship are 2 line, 1 line, and no line. So for department arrangement, for first row is A, B, C, D, E. Second row is F, G, H, I. The best arrangements by using the pairwise exchange method is for the iteration is C, B, A, D, E, F, G, H. Transportation is 2,000 meter. Chosen layout for the production flow plan. So for line balancing technique, in the LCR and rank positional weight, the line balancing efficiency is 90.1 and line balancing loss is 9.9%. This minimize the idle time and balance the workload. Hill Bridge and Wester method, for the line balancing efficiency is 72.08%. Line balancing loss is 27.92%. So this moderate efficiency needs refinement. So the line balancing techniques provide a visual precedent diagram, so which highlights the task sequence and dependency, identify important path and possible bottlenecks. For the parking space layout, we can see that the parking stall dimension with wide 2.79 meter, depth 3.96 meter, module dimension wide is 17.4 meters, depth is 20.86 meters. The traffic flow show that the direction indicated by an arrow, spacing zone, and measure the Y equal to the measurement Y equal to 1.34 meters. Design goals is adequate vehicle space, efficient area utilization, reduce congestion and accident, suitable for urban environment. So next, for conclusion, the three of the objectives are achieved, and by use the SLP and pairwise method to create and analyze the layout alternative. And also for the best layout is CBADEFGHI. Lowest total transportation is 212,000 meter. Parking space designed for 13 workers. And the next one is LCR and rank positional weight method are used for line balancing with the efficiency 90.1%. So the limitation is budget constraint not considered, and also the surrounding environment is not considered. Suggestion for future works is use more accurate and larger data sample, ensure practical and feasible production layout. So that's all from our group. Thank you.